In this video, we're going to be taking a look at an inclined plane problem where a mass of 5 kilograms has an initial velocity of 8 meters per second going up a 30-degree incline, and we're going to see how far up the ramp it travels before it comes to a rest. Now, we're going to approach this by using some energy ideas. Now, we know that if energy is conserved, then all of the initial energy is equal to the final energy. Now, if we're taking a look at the situation as a frictionless surface, then in the beginning, we have just kinetic energy, some initial kinetic energy. And then at the end, our kinetic energy is going to go to zero. And then we're going to be left with gravitational potential energy, which we'll either write as UG or you could write it as PEG, either one. All right, so we know that we have some initial kinetic energy, which is 1/2 mv squared equal to mgh. And it turns out that the mass is insignificant and that's going to drop out. So let's go ahead and plug in some of our numbers and solve for our h value. All right, so we found an h value of 3.26 meters, which is not our answer. But we took 1/2 times basically 64, because 8 squared is 64, and divided by that by 9.8 to get that height. So that tells us that we went up 3.26 meters from our baseline height of 0. And with that, we can get our final answer. We just have to use a little bit of trig. So we have the opposite side from our 30-degree angle, and we want our hypotenuse. So we can fairly easily get our distance d. So the sine of 30 degrees, which is equal to 1/2, equals the opposite, 3.26, over the hypotenuse, which is the distance d we're looking for, and we can go ahead and cross multiply those two, which those are going to switch spots, and then our distance is going to equal 6.52 meters. So to sum things up, if you're looking for a problem where you are taking a look at a mass going up an incline, basically what you're going to do is set these two types of energy equal to one another, assuming that you're neglecting friction, and the masses are going to drop out. From there, you can solve for your h. Your h value is going to be your height away from the surface of the Earth, or at your baseline level of 0 meters at the beginning of the problem. And then you can go ahead and use that height as your opposite side of your right triangle and find that hypotenuse by using, like I said, a little bit of trig. We use the sine of 30 degrees, and then we found our distance of 6.52 meters. So I hope that was helpful in helping you find the distance moved off the ramp. Thank you for watching and listening.